You're listening to Cultivation Elevated, hosted by Michael Williamson and Anders Peterson, where we discuss vertical farming and the future of cannabis and food production.
Hey, what's going on, everyone? From Pipp Horticulture, I'm Michael Williamson, along with Anders Peterson, and you are listening to Cultivation Elevated, the podcast where we dive into all things cannabis, food crops, CEA, and vertical farming. Today, we're excited to share some insights on a research facility that we've been building out with the Cannabis Research Coalition. And Anders was on site for like almost 2 weeks on that project. So, Anders, I'd love to hear, more about what this project is, how long you've been working on it, and why is it so important?
Yeah, this project has been almost a year and a half in the making. Um, we have worked, I don't even know how many hours on getting this all coordinated, designed, and built, but it has been a really fun project to be a part of. Yeah, so with Pipp Horticulture, the way this all kind of came about was obviously we care about our customers' success and we try to understand their challenges and strengths and opportunities. And, we have found that airflow can be a limiting factor in a lot of these vertical farms. And when myself and you and other members of the team are trying to help our customers with airflow, there's not a lot of information out there to quantify it. What are the right airflow velocities? At what light intensities and stage of growth of the plant in? How much airflow should we be delivering? There's just no information out there. And so the leadership team at Pipp decided to be a good idea to work with a third-party researcher, Dr. Allison Justice of the Hemp Mine and Cannabis Research Coalition, to investigate this, to really understand is top-down or bottom-up airflow a better route in vertical farming? What velocities in prop, veg, flower, and drying are best for photosynthesis and transpiration rates? And investigate the optimal air velocities and how it affects the plant growth. And so that was really the metamorphosis of this, and the beginning of this was we have some questions, let's answer them. And a third party accomplished researcher such as Dr. Justice is the right person to do it with instead of trying to do it in-house. So what we did was we created some experimental designs. We outlined our goals of the research, and then we needed a facility to conduct the research in. And to do that, we brought in a lot of other vendor partners. We reached out to other vendors in the space to see if they'd be interested in working with us on this. And the responses were quite positive. So we have a number of really top tier equipment vendors in the space who are willing to donate equipment and their time to help us make this project, turn it into fruition. Real quickly, some of those vendors or all of the vendors that agreed to partner with us on this project is, obviously Allison, Cannabis Research Coalition, and the Hemp Mine, Pipp and Vertical Air Solutions, Libra Design, an LED lighting company specializing in research grade and custom LED fixtures. We have Cannabis Irrigation Supply, helping us with the design and supply of our fertigation system. GrowLink, important part of this process for data collection, controls, automation. PlantCO2.com, helping with our CO2 supply, supplementation and supply, and life safety. Quargrow, a good substrate company, provided us with some 2-gallon easy fill cocoa coir bags. Athena for nutrition. They've been really helpful out, providing us with fertilizer for this trial. And Andin for dehumidification. They've been a big help making sure these rooms are properly sized and will be controlled well with humidity. And then last but not least, Grovera, a newer company on the scene, a startup providing analysis on drying and curing. So it's a device that you can clip onto the plant in the dry room to understand the moisture content and water activity of the plant. So during drying. So all of these companies we've been coordinating for about a year and a half, trying to get these rooms built, designed, and operational. And so finally we got everything figured out. Myself and Brian Tatro of Pipp Horticulture, one of our project managers, he's been a huge help for me on this too. He's a really handy and smart guy, and I couldn't do it without him. But we were out at Allison's facility in South Carolina for 10 days. We probably, when we got there, it was a shell of rooms. We had to install lights so we could actually even see in them, running lights. And in 9 days, we took it from an empty shell of a room to three fully functioning identical grow rooms and one dry room.
Can you
It was
describe
an
those a
effort.
little bit more in terms of maybe like details on size or scale? Typically with research, you don't always need the largest room, but you need the most amount of control.
Yeah, that's a good point. I mean, a research facility versus a commercial production facility are two different things, right? And a lot of the smaller scale of research is due to making the data statistically significant. So,
Hmm.
can you collect enough data points in a large commercial facility to have any true confidence in the data you're collecting? That's really hard. That's why a lot of research is done at a smaller scale. So these three rooms that are identical, they're all roughly 12 feet by 8 feet in dimensions with a 9 foot ceiling. We have one 4 by 8 tray in each room, so 32 square feet of canopy. They are on PIP racks, on tracks, mobile racks, but it's only single level. But we wanted to design it as if it was a multi-tiered facility. And so the lights are still mounted to the racks, VAS is mounted to the racks. The um, supply for the HVAC comes into the front. The dehumidification is supplied to the front of the room, and then it's returned in the back of the room, similar to how a commercial multi-tier facility would be designed. So a single pass recirculating climate control system. We have fully automated drip irrigation. GrowLink has allowed us to fully automate and control every parameter, including CO2 supplementation, lighting. We have our VAS fans integrated. Um, and then an important part of this too was airflow sensors. So we spent a lot of time finding and testing and selecting sensors to integrate into GrowLink for 24/7 continual monitoring of airflow.
Because airflow is such a kind of, I don't know, gray area might be the word, but depending on who you talk to from a grower perspective, they all have a lot of different takes on how they like to move air, how much air they move. Um, for someone that's maybe interested in dialing in their facility, I guess I'd be interested in knowing more about, I guess, how did you make that selection on the airflow sensors? And if you can share maybe the one that you settled on and why.
Sure. Um, there are a lot of different handheld um, airflow sensors and different really technologies for measuring airflow out there. But we're targeting airflow ranges in feet per minute between 0 and 500 roughly, right? Maybe 0 and 1,000 for a slightly bigger range. And that may seem like a big range, but it's not compared to some of the velocities that are used out there in mechanical systems and even outdoor airflow, like if you're on the top of a hill measuring it. So there's only a few tools that can be sensitive enough to get stable, accurate readings at, let's say, 100 feet per minute, right? So we selected a hot wire anemometer.
Hmm.
We've talked about those before on the podcast, but essentially it's a little wire that's heated up to a set point, and as air goes across that hot wire, it cools it down. And the voltage required to heat that hot wire back up to set point correlates to the amount of air velocity going across it. So it's very sensitive. Um, but within the world of hot wires, there's two broad categories. There's unidirectional and omnidirectional. We chose omnidirectional because it captures from all directions around that hot wire or bulb. So you get a broader view of the airflow in these kind of turbulent environments compared to something unidirectional that is meant to stick into an HVAC duct and get air going in one direction only.
Hmm.
So we have multiple omnidirectional hot wire anemometers mounted on custom sensor mounts that our engineering team built and 3D modeled parts for, which was really cool to see.
Because they're handheld tools that you've then modified, are they meant to be permanently placed in like hardwired in?
So I worked with a company called Degree Controls.
Hmm.
They're one of the few companies out there that manufacture omnidirectional hot wires. and they had experience installing them in cannabis cultivation facilities before. So these are custom sensors. They weren't more expensive than a handheld or anything, but they made them for us custom to get the right outputs to integrate into GrowLink and just to have the right form factor and calibration for the velocities we're targeting. So we have, I believe, 20 of them. I mean, they're not cheap, but we have as many as we could get per room that are all hardwired back into GrowLink. And we can get 24/7 trending. And then with these adjustable mounts that our engineering team devised, they can be easily adjusted to constantly be at the top of the canopy, similar to like how a PAR sensor is running in these facilities.
How many inches off the top of the canopy are you targeting for this trial?
Right now, we're testing that, but right now what we're doing is 2 inches
Okay.
at the best average height of the canopy we can. So
And then with all 20 sensors, is that in one research chamber or room, or is that throughout divided between the three
divided between the four.
or the four? Okay.
Yep.
And then
So
it takes averages, plus it'll show you independent zones essentially.
yeah, so if you think of a 4x8 tray, there's one in the middle, four on each, like one on each corner.
Mm-hmm.
So we have
Makes
five.
sense. Nice.
And then the dry room is a little bit differently. We have airflow sensors in there too. We're going to be looking at the whole kind of myth of pushing or pulling air through a dry room, which is better. How much airflow on the plants, how does it affect the moisture removal rate of the room? Different velocities in drying too. So we have airflow sensors there. And then, of course, we have some high quality handheld airflow sensors as well, just to validate the degree sensors and just supplement the data. So,
Yep. Nice. I was thinking about it while you guys were doing that try or while you were building it out, and you know, you have one 4x8 tray, so by all, commercial standards, it's quite small. But there's a lot of things that are applicable that a small cultivator has to go through as well. And you and I have talked about this before, where when we get, hey, I'm going to design a 40,000 square foot facility or 30, 25 even. You're like, okay, great. And you have kind of a lot to work with, and you can really kind of lay out a bunch of different options. But when you start to get into like, I have a 10,000 square foot facility or a 7,500 square foot facility or a 5,000 square foot facility or less, it's really challenging. I think it's a lot harder to design a small, like when people get a micro license in some of these states, like I spend way more time helping support that design than I do on like a large scale facility. And you're doing an even micro version of the micro. So yeah, can you talk a little bit about kind of, I guess, the decisions that you made to make sure that, every really, and this, we talk about a lot about like square and cubic foot maximization, but when you start to get into these, smaller chambers, it's like now all of a sudden like cubic inches kind of matter.
yeah, I agree with you. So a lot of the times it's actually easier to design a larger commercial scale building than these smaller rooms. One of the reasons being is, when you're doing research, you want as tight precision control as you possibly can to eliminate variables that could influence the data and research. So when you're talking about precision controls on a small scale, especially doing within a budget, that's where it gets challenging because a lot of the high performing precision equipment is meant for bigger scales, at a
Hmm.
larger dollar value. So how do you get that level of precision within a reasonable budget? And fit it all into a smaller form factor and make it look clean. That's tough, and so it just takes a lot of planning, a lot more planning um, at times than some of the larger buildings where you have a little bit more space. Like, for example, all the sensors that we have on this one 4x8 carriage, it's a lot of wires coming off one rack. So how do you deal with cable management with all of these sensors, all of this technology in a small footprint and not make it get in the way, still make it look clean? Um, yeah, it can be just a little bit more challenging. Some of the best equipment out is now built for bigger scale. And
Sure.
so That's why it was really nice to have the vendor partners we were able to get on this project because their equipment helped solve a lot of those problems.
Well, when I think about like little things that maybe people aren't thinking about, like every time the door opens on a smaller room versus a larger commercial facility, it has a significant impact on the swing of all kinds of things in that room. You know, I'm assuming that you guys probably put your Andin dehumidifier on top of the lid and duct it in.
We did, yeah. So we had two 70 pints. Everything was slightly oversized, just so we had the control, and to account for any infiltration, exfiltration in the structure. Even though it was quite well sealed and everything is siliconed and everything, we wanted to keep the equipment out of the room to prevent microclimates, with such a small space. And so they're ducted, and we built some custom kind of mounts for them on the cap of the structure. And then we used duct and penetrated into the front and back. So we have two dehumidifiers per room with the supplies in the front, returns in the back.
Hmm.
Um, we had to go with a mini split type air conditioner just due to cost and size. Um, but again, that is in the front of the room, delivering that cool, now dry air where the DUs are coming in into the VAS system. The intake is in the front as well, moving it down across the table, but there's returns in the back where we can pull from. So with that volume and the size of equipment, we're doing, I believe it was somewhere like 25 to 30 air exchanges an hour.
Okay,
Um,
nice.
yeah, and
Yeah,
we can run them in fan mode too, so that even if their compressors aren't kicking on, we can still have that air movement until the compressors need to kick on. So
nice.
we integrated the HVAC units with BACnet, where we can get a lot of interesting statuses, points coming off of those mini splits, understand when the fan's running or not, the compressors are running or not. Whole lot of interesting data.
It's amazing how many people. I remember I was down in Puerto Rico touring around at cultivation facilities this past summer, and I saw a lot of I don't know what I'll call like traditional designs. So they had pip racking and they were going multi-tier. They typically had a more commercial but not necessarily integrated HVAC, and they had a series of independent dehumidifiers that were kind of hovering and hanging over the main aisle. And they had asked me, they go, these things kind of put off some heat, and what's the best way to mix these? And it's amazing how many people are not aware that they make these ducting kits for them that bolt right on. They're not typically sold. It's usually in the accessory side for, I believe, any of the major brand independent dehumidifiers. And when I pulled it up on my phone real quick and showed them, I mean, it was like you could see the light bulb went off, and they were so pumped. I mean, they were pumped anyways because they just had that kind of Puerto Rican energy down there. And this American guy is kind of showing up and checking out their stuff. But I do see that quite common. And so people don't realize they're like, well, I need these dehumidifiers. And it's like, yes, you do. But, you also need to make sure that they're not necessarily short cycling around them because of where the supply and returns on. You kind of create this little heat and some, dry air kind of like, I don't know, like buffer around the unit. But now when you can duct them, if you have the ability to put them outside the room, that's always my preference, and then duct them in. But even if you're going to leave them in place, you can at least go duct that return, downstream or wherever it is that aligns best with how your HVAC is.
Yeah, it's definitely more work installing dehumidifiers outside of the room and ducting them than it is just hanging them in the room on some threaded rod and unistrut. It's more work, but there's a lot of pros to it after you get them installed. Also, there's limitations, right? So there's duct length limitations for how far you can duct these units. Like we're running these smaller 70 pint per day units, two of them per room. But you can only do 8 feet of duct on either end because there's
Hmm.
limitations to the fan inside that unit. Um, there is potentially some decrease in capacity by ducting them, especially if you go over that limit that the fan can overcome. And then you got to worry about things like condensation, for example. So if it's outside the room, is water condensing, and do you have a catch pan to get that condensate underneath the DUs? It's all pretty simple to do. It just takes a little bit different planning than hanging them in the room. But like I said, it makes it a lot easier. Um, and we need to go change those filters. You don't have to do it in the room. You can do it outside. Um,
I've always liked
but
that minimalistic approach. I've gone to, like hundreds of facilities, and sometimes I recall, and I've seen it a little bit less these days, but I love when I go into a cultivation room, and I personally in my life attempt to be a minimalist. And so I kind of love like nothing in a grow room where it's like racks, plants, fans, lights, and that's it. And everything's kind of white and sterile and clean. But I've been into facilities where, you can almost tell they were either really susceptible to salesmanship, and they went to like maybe MJ Biz for the first time, and they just have like one of everything on the wall, and there's so much
yeah.
stuff. A lot of times it'll conflict with each other, and a lot of times it's not necessary. It reminds me of this time I was down in Mexico for work, and we were looking at we were visiting a tissue culture lab that specialized in bananas, Cavendish bananas. And they originally had a lab manager, and they had like all this state of the art, quote unquote, stuff. They spent a fortune, and they just couldn't. I mean, by all means, their investors looked at it and said, we've got the state of the art, this thing, it's going to work out, it's going to operate great. And they were having terrible success rates. Long story short, they ended up letting that lab manager go. They brought in a new lab manager, and the first thing they did is they just started taking all this stuff away. They went back to like a very simplistic way of doing things, and now it's a thriving tissue culture company. So sometimes people invest in an excessive amount of technology that doesn't
Mhm.
always integrate well. And actually can be kind of part of their demise, or part of the restrictions on why things aren't performing. Um,
Well, on the flip side though, too, it was definitely a grind getting these built because we had a time limitation where Brian and I could be on site to actually get everything constructed and put together. So we worked some long hours, but Allison's team at the CRC, she had a guy on site, Thad, who is a super handy guy. We had our buddy Zach come help with some plumbing. So we had her cultivation associates help us out with some things. Allison got her hands dirty and she was punching
nice.
lines and drip lines, and she helped us do some cable management, and she just jumped right in and helped too. So it was pretty fun. It was kind of like a bonding experience with the team. But some interesting comments Allison made was, with the Cannabis Research Coalition, they do other studies beyond what we're doing with them, right? Outside of Pipp. And this technology and the way this was constructed with the automation benefits her team immensely because it allows them to still maintain a lot of care and precision in our study, but also have the time and ability to focus on the other research projects they're conducting. So in this instance, the technology, we chose the right technology and the right amount of automation so that we could do quality research, but also not require 24/7 attention manually and changing every dial and going in there with handheld tools. It allows her team to also still conduct other really important research.
So this important research, and we had talked about this before, but it's not uncommon for a commercial cannabis facility to have a room that's labeled R&D. And it's usually a
Yeah.
smaller room in a lot of cases. And they're like, oh, we do research and development here. And I would say, and it's not all cases, because there are, we know that there's PhDs on some of these larger teams that actually are doing like real serious science and research. But I would say the vast majority of people are operators today that have a quote unquote R&D room, they're really not doing much research. And it almost becomes like, oh, we do like phenotypical selection in this room, or we're
And they call it
testing a new
R&D.
light,
Yeah.
or we're trying this other nutrients in here. And I don't want to discredit that, but what we're trying to do here at Pipp with Allison, at the Cannabis Research Coalition, is very different. And we're not trying to, sure, we want the data too. We want to know as well what is the best optimal thing, but we're really doing this for our customers. Pipp being
Yeah.
a customer-centric, grower-centric company, we want to be really confident when we speak to growers. And when growers have an opinion, we always want to listen to it, but we also want to say, hey, you know, take this information for what you will. Here's a collaborated and third party research trial we did, and here's the data and the results, and here's what we found. And so I think what's really neat about this project with Pipp and Allison and the Research Coalition is we're doing this for the people. We want to get this information out. We're going to make all this information public. If you are in the build out process and you're trying to make some of these decisions and you haven't spoken to someone at Pipp like Anders or any of our incredible sales team members or anyone from engineering, we're trying to share information because we want to see people be successful. We want to take some of the guesswork out of this. And so we're putting a tremendous amount of energy, capital resources. And I mean, this trial is, we're talking about a multi-year project just so that we can help growers better understand airflow. And that I know of, and I'm sure there's somebody somewhere doing something similar, maybe, but I don't know anybody that's trying to do something like this for growers. We have a pretty good understanding about lighting. We have a pretty good understanding about nutrition, but this, airflow velocity and what to target and how much is too much and how much isn't enough. And like you said, is it super canopy or sub canopy? Um, I know I have like what I believe my preferences are, but I'm not set in
That's the
stone as a
point though,
grower, you know?
right? Belief.
Yeah,
That's what we're trying to get past is, you know, that's what I get a lot too is like, well, my leaves aren't dancing or my leaves are dancing too much. It's like that's subjective, it's feeling based. And that's what we're trying to get to the bottom of is let's put some real research to it and get answers to these questions. And from something you said earlier, this information is going to be public. We're putting it out there for everyone to see. We'll be able to do 4 trials a year, so essentially one a quarter. We'll be vegging and flowering, in the same spaces, collecting data at both phases of growth. And then all rooms will be harvested at once. So they're running simultaneously in the same stages. They will be all harvested at once. And then the dry room is sized to fit all 3 rooms harvest. Um, the reason we chose 3 spaces was that one can be a control when we do an experiment, and the other 2 can be test parameters. So we're able to have a control and 2 test parameters going on at the same time. Um, and it's research. Part of this is going to be killing plants. Like there may be some rooms that just look like fire, and we're going to be running them with all modern cultivation strategies, precision irrigation techniques, managing the climate with, energy balance kind of equations and approaches to VPD. But we're purposely going to give certain rooms not enough airflow and certain rooms way too much that we know is too much. But let's find that balance of like, what are those limitations? And how does it affect the photosynthetic and transpiration rates of the plants? How much does it increase your crop susceptibility to pests and pathogens? What are those kind of guide rails? And then putting it out there. And we're calling this the Pipp CRC Research Center in collaboration with all of our partners. And yes, we're initially the main focus of it is airflow. But what's cool is now it opens up doors with all of this collaboration to study other things, whether it be simultaneously along with airflow, or just other completely unique research projects down the road. Essentially, this is just opening doors to a lot of possibility.
sure.
And the main focus right now is understanding research, but we have all kinds of ideas we've been discussing with other vendor partners and between Allison and I and her team.
You
So
guys are gonna be doing
it's
full COAs on all this stuff?
oh yeah, yeah,
Yeah.
full
So it'll be interesting,
COAs.
right? How does airflow impact terpene? How does airflow optimal or suboptimal impact, obviously yield, potency, growth characteristics?
Well, like even lighting level, I think is a big one to me, right? Because light is one of the main driving parameters of plant growth, right? It is the top one in my mind. I set light first and then balance everything else downstream according to the light level. Um, and when you look at airflow research in other crops, um, how much light are those crops getting? So generally, you see in greenhouse crops stuff stated where it's like 100 to 200 feet per minute is generally okay for most of these leafy green or pepper or cucumber type crops. But they're getting what? Between 100 and 500 micromoles, maybe 600 micromoles of light. We have double that in cannabis. We have 1,200 micromoles in flower, sometimes up to 1,500. So all of that extra energy coming into the crop needs to be balanced. And so if you just stick with the general parameters of, yeah, between 1 and 200 feet per minute is generally okay for airflow in a greenhouse for most crops, it's just not going to translate to cannabis because we have so much more light radiation coming in, and we're pushing these plants in such precision controlled environments that they're photosynthesizing faster, they're transpiring faster with more volume. And so you need to understand how much more airflow do I need to balance that whole just fast metabolism and growth rate. And if you think about it, like, okay, say 100 feet per minute works for one crop, but our estimates are maybe cannabis under that much light requires 300 or maybe more. I mean, that's a doubling, tripling of a parameter. That's
Mm-hmm.
significant. That's not like, oh, we need it 10% more. No, we need it 200% more, right? So it's pretty significant. And airflow, when you look at energy balance, like balancing all these parameters, and energy balance equations, for those aren't familiar, are a way to understand how to balance all of your growth parameters instead of in a monofactorial way, like looking just at temp or RH, but how do you combine all of it into one thing that they each balance each other to make sure you don't have a limiting factor of growth. Um, it's an area of study called environmental biophysics, if you guys really want to dive deep into the rabbit hole. Um, but it's really cool because you can kind of come to a math answer of what you think might be the answer for airflow because you can solve for X as a variable, airflow as a variable. Um, but you still got to back that up with research. Does it
So
actually
we
work in practice?
we right now, and this is, I guess, the collective industry of people that are trying to figure out airflow. We believe that the target is roughly 300 feet per minute.
I would give it a range. I would say in veg, generally, without more
I'm
research,
sorry, yeah, and
between,
flower.
yeah, in veg between 100 to 200,
Hmm.
generally. And then in flower, anywhere from 2 to 300,
And the
right?
reality is we don't know.
No one knows. That's why we're doing this. It's novel research. So it's going to be pretty interesting to figure out.
Those are pretty awesome. I think we'll obviously be doing kind of updates. So as you guys are having harvest every quarter, we'll be touching base on the airflow through the podcast and through other channels, our website. We'll make sure we have Allison Justice on here regularly to kind of give, firsthand reports on what's going on. That's going to be really exciting. And I know that there's so much that, growers and operators have to take into consideration. And I know there's some fellow nerds out there that are really going to like eat all this up and enjoy every minute of it. And then there's other people that are like, I just want to know the answer. Like, just like, I want to know what the final answer is so that I can just go implement that because I got a million other things going on. So I feel like, in the end, when we get through this and we really kind of have these aha moments and feel really confident about the information, I think this information is going to be helpful for pretty much just about everybody. And that's pretty
Oh, yeah.
exciting.
Oh, yeah. And beyond that, too, for the design phase, this is really important information, right? We're engineering around the physiology of the plant. And so even engineers will benefit from this. Equipment manufacturers in the HVAC industry will benefit from this. Obviously, Pipp is going to benefit from this with the development of future airflow systems. It'll direct what products we develop, whether we more sub canopy versus top down type airflow systems. Directionality is really quite interesting in airflow and vertical farming. Does blowing air from the bottom up help with CO2 assimilation rates and photosynthetic rates? Like, when are these top down versus bottom up strategies valuable? Does it make sense to run them the entire cycle or just in the beginning of stretch? Like, really hone it in. So, yeah, it's going to help a lot of people.
Before we wrap up this initial podcast on this series, what's your thoughts on why someone hasn't done this before? Like, why is this why is this such an overlooked area? It's like we've really drilled down on almost everything else, and this one's still kind of gray.
I don't think we have drilled down on everything else. I think lighting and nutrition definitely has been the majority of the studies
Hmm.
I've seen done by academic institutions and other, private companies. like equipment manufacturers and such. There's technical limitations. It's challenging. Obviously, there was limitations in the sensor technology available for us to do this. I mean, we had to essentially get custom sensors, and there were only a few companies that could actually do it. Um, yeah, it's just it's maybe not, I hate to use this word, but as sexy as some of the other research
Sure,
you could be
sure,
doing.
sure.
Like I've always been kind of a nerd with climate, like VPD, temp, RH, and airflow, but it's invisible to most growers. It's not tactile. It's not something they look at every single day. Whereas like nutrition, it's something you're hands-on doing day to day in your grow. You're mixing your reses, you're filling your stock tanks, you're sending your irrigation events. Um, Climate can be a little bit out of sight, out of mind, but I think what's happening though is you're leaving a lot of yield on the table by not focusing on it more. There's tons of studies in other crops like tomatoes and leafy greens where better adherence to VPD control results in anywhere between 10 to 30% increase in yield. So if you think you're maxed out, but you haven't optimized your climate, that's the area where you can truly get significantly more yields. Like it was kind of like when you didn't inject CO2, but now you're injecting CO2 and your yields went up 20% or whatever. Like this is kind of that last area to where if you really haven't paid attention to the environment above the root zone, the climate, um, that's where the next big jump in yields, I think, can be done. Um,
Yeah, I agree with that. I also want to acknowledge that for a lot of groups, there's going to be reduction in labor components as well. So, as an example, a lot of people get dependent on like some type of IPM spray program because otherwise
mhm,
they deal with, let's just powdery mildew as an example. And they're like, okay, I use, could be micronized sulfur, it could be a bunch of different stuff, but they're like, okay, this is really taking care of stuff. But, that stuff has a cost. It has an impact on your crop. It and it's a there's a labor component to it. And so if you're able to have adequate airflow, there's a decent chance that you can reduce some of your operational cogs. Um, the other thing that I want to mention is, I never want to discredit the grower. And as growers, we walk into a space and you can blindfold a grower and have them walk into a space. And yes, the first thing they do is they look because we have eyes and that's just how we operate as human beings. But I find that true growers, when you talk about this, they're like, yeah, spot on. They can close their eyes and they basically smell and feel the room when it
yeah,
comes
you
to
can tell when
environment.
a room doesn't feel right. You walk into flower like this room is way too hot, way too humid, way too cold,
Stagnant,
way too
or yeah,
dry.
you're like, there's a smell here that doesn't belong, and you kind
Hmm.
of start doing that thing too. And people kind of look at you like you're crazy, but like other growers know, like, all right, this guy's legit, or gal. And so one thing I've noticed around airflow is the growers are really looking at it from a visual standpoint. We'll add some additional fans into a setup where we feel like we have maybe inadequate airflow because, that space didn't have like VAS, Gen 2 as an example. And so, the grower will come back and be like, oh yeah, I can really feel the airflow now. And yeah, the leaves are dancing or tickling or whatever, vernacular they're using. But the reality is like the majority of them are not measuring this and they
Hmm.
don't realize that maybe what you can feel as a human that you think yeah, sure, maybe there's more airflow. The question is it enough? And if you're not measuring it, is that airflow uniform throughout the crop? There's that measurement tool, and it seems like a lot of growers um, aren't measuring airflow enough. And, through your help, I went through a monster airflow exercise up at a Bostica up in Massachusetts. And I can't tell you, yes, was it time consuming? Absolutely. It took me like 3 days and I didn't even get through 100% of it. And I'm going to go do some more next week. But I learned so much more about that facility by just taking those 30 samples over a 30-second period for a 4x8 tray and moving slower through the room. I was able to absorb, as a grower, you're trying to cover a lot of ground, you're doing your walkthroughs and just trying to manage operations, but taking the time to slow down to really understand what is the airflow in your room. And if you buy some of these tools like the hot wire anemometer that you mentioned, which aren't expensive. We're talking about a $150 tool, or depending on which one
Oh,
you buy, maybe up to 500
Less
bucks.
than $1,000 for even the
Yep.
really nice ones.
So, and if you take the time to do this, you will learn, if you do an air mapping exercise, you will learn so much more about your room than you could have ever understood as just with your grower senses alone.
Yeah, I couldn't agree more. It
Well, I didn't think this episode would go this long, but there's kind of a lot going on, and I'm excited to kind of have the next one. And yeah, it'd be great to get Allison on the next one, so we'll coordinate that. And as always, if you ever have any questions, you're working on a new design, um, Pipp Horticulture. We're here. We're easy to find. You know our names if you're looking at this stuff, and you can get a hold of us directly. We love to help people. We love to
Mhm.
support growers. We want to see people be successful. I always say, I want to see you have your phase two. And so anything we can do to contribute to your success is an honor for us and something that we welcome. So
I also want to just give a quick shout out to the leadership team at Pitt for seeing the value in doing something like this. I mean, it was really awesome for them to see like this is important. Let's do it. Let's commit to it and invest the time and resources into answering these questions for our customers. So thank you for that. And I also just want to thank Allison and her team for helping us out during the actual construction. They were a huge help to get everything built and done, and we had fun with them. And I'm stoked to be collaborating with them ongoing throughout this research trial. So there'll be a lot of other trips out there to South Carolina to spend with them, spend time with them. And also, if, depending on when this episode comes out, if you be at MJ BizCon this year in 2024, Allison will be at our booth for a meet and greet the first day. So please stop by. You can chat with Allison about this trial, ask her any questions about the other research she's doing. I'll tell you right now, it's an honor for me to work with Dr. Justice. I've known about her since she first came into the cannabis scene, 7, 8, 9 years ago. She was one of the first people to really start answering some of these questions that we were all guessing on. And that just blew my mind. And I instantly gained a ton of respect for her. I'll admit I was kind of a fanboy of hers for a long time before I actually got to know her and become friends with her. So now getting to collaborate with her on this is just awesome. I have a ton of respect for her and what she's done for this industry, kind of blazing the trail and really trying to put hard science to a lot of this kind of bro science that's been in the industry for a long time as a good research, like good resource for the industry. So, yes, thank you, Dr. Justice, for also working with us on this.
love it. All right. Till next time, folks.